Hello students, welcome to another video lesson. This is Mr. Garcia saying hi, and this video lesson is going to be over conditional statements. Okay, and again, this is something that you've been experiencing, okay, in life, and you might have a question as to why is this in a math class, because it's all just words and it seems like it's English, but this is like the foundation of mathematics. Okay, math is based on logic. So what you're going to see today is just based on logic. It's just words on a math course. Okay, so let's go ahead and get started. So this is notes 2-2, conditional statements. Okay, so if you want to pause the video so you can copy this. Now, don't worry about getting a perfect circles here. That's not the point. You can just, as long as you have something that you understand, it's fine. Okay, so real quick, this you've seen before. This is called a Venn diagram. Okay, and we see that inside of this Venn diagram we have the quadrilaterals, which is the big circle, and the squares, which is the small circle. So I'm going to make a statement about what this Venn diagram is saying, but it's going to be in words. So in words, this Venn diagram is saying that all squares are quadrilaterals. Okay, that's what this is saying. So this will be the statement that this Venn diagram is giving you. So let's continue. All right, so now I'm letting you see this part here. Okay, and I'm going to uncover and fill in this paper with information that will help you understand today's lesson. Okay, and today's lesson, like I said, it seems like it's just words, but this is how mathematics works. It's based on logic, and logic has a lot of if and then statements, and you have experienced those with your parents. Like, for example, when your parents say, if you pick up your room, I'll let you be on your phone for how long, I don't know. It could also be, if you pick up your room, I'll let you play your video games. So that's a conditional statement. Okay, so you have experienced this in real life. So a conditional statement, okay, just uses if and then. So what I'm going to do is I'm going to turn this statement into a conditional statement. Okay, so to do that, what I'm going to do is this conditional statement has two parts. The first part is if, the second part is then. So if is what we call the hypothesis, and then is the conclusion. Okay, so if I were to turn this into a conditional statement, I would say if a figure, okay, if a figure is a square, then the conclusion is that it is a quadrilateral. Okay, so if a figure is a square, then it is a quadrilateral. So I just turned this statement into a conditional statement. Now, what's important about this one here is that we can agree or disagree. We can say, well, this is a false statement, this is a true statement. On this one, I'm just saying all squares are quadrilaterals. I don't care about what you think. But now I'm giving you a chance to argue with me. Is what you're saying true? Just like lesson 2-1, remember that you have inductive reasoning, you have conjectures, and you have counterexamples to contradict or prove conjecture wrong. Well, that's what I'm able to do here. So if I make this statement, which is a conditional statement, you and I can discuss whether this is a true statement or not. Okay, but this one we cannot. Okay, I'm not giving you a chance to even respond if I say it this way. All right, so let's separate the two. So this is what I said. This is what we call the hypothesis. And you have seen this in your science courses. You know, you have a hypothesis and then you do some research or lab work to make a conclusion. So it's like to make it turn into a theory. So then this one here, this part is what we call the conclusion. Okay, but in math, we use some notation here. Okay, so the hypothesis, we usually use P. Okay, so P represents a hypothesis and Q represents a conclusion. So if P, which is the hypothesis, is true, this arrow means then Q is true. So if the hypothesis is true, then Q is true. Now, let's think about this. Is this a true statement? Okay, what I'm saying here, if a figure is a square, then it is a quadrilateral. And the answer is yes, this is a true statement. So for this one, this is a true statement. Okay? And if you disagree, try to find a counterexample that contradicts this conditional statement to prove me wrong. But this one is a true statement. Okay? So the truth value, when you say truth value, that means is it true or false? So don't let this confuse you. When the question is asking, okay, what is the truth value of this conditional statement? What it's asking you is this true or false? And if it's false, don't forget you need to provide a counterexample. You can't just say it's false. You got to say why it is false and give an example of that makes that statement or conditional statement false. So let's go on to the next term. Okay, the next term is called the converse. Okay, the converse is the following. So the converse is going to switch the hypothesis and the conclusion. So notice, keep in mind, P implies Q. We are going to switch. Q implies, so this will be Q and this will be P. So they're going to switch. So that means the hypothesis is going to take the place of the conclusion and the conclusion the place of the hypothesis. So I'm going to just add here that this, the converse is just backwards. Okay, backwards. Switch the hypothesis and conclusion. So I'm going to change on this one. Okay, so I'm going to say if a figure is a quadrilateral, okay, then my conclusion is that it is a square. So I'm going to change the symbols here. So this will be Q is not the, it's now the hypothesis. So this is Q and this is P. Now I want you to think about the truth value of this one. Is this true? If a figure is a quadrilateral, then it is a square. Is that a true statement? Is it? And the answer is that this one is not. Okay, and I can give you one counterexample because it's saying if a quadrilateral is if a figure is a quadrilateral, then it is a square. So this is saying this is bigger, this set of geometric figures is greater than this one, and in this case specifically quadrilaterals. So one counterexample, how about the rectangle? How about the rhombus? What else? The trapezoid, right? They just have 4 sides. That's the definition of a quadrilateral. So the answer is this is a false statement. So the truth value is that it is false. And I hope that makes sense. So find any figure that has 4 sides that is a quadrilateral that is not a square. Okay. All right. So let's go on to the next example. And again, don't forget I just switched the hypothesis and conclusion here, which is what the converse does. So let's go to the next one. The next one is the inverse. Okay, something that I need to add here about the inverse is that for the inverse, converse and inverse statements are, we call them equivalent. Equivalent just means that they have the same truth value. So if the converse is false, then the inverse is false. If the converse is true, then the inverse is also true. Okay, so just keep that in mind. Now the inverse, what does the inverse do to a conditional statement? So this is what the inverse does. The inverse is going to negate. Okay, the inverse makes the statement negative. And this is how it does it. Okay, it introduces this word, not. Now let's see how this works. So this one negates the hypothesis and conclusion. So then all I have to do in this case to negate, okay, the hypothesis and conclusion is I'm going to go back to the original conditional statement. So if a figure is a square, then it is a quadrilateral. I have to negate this one and this one here. So I'm going to say here, if a figure, and this is what I'm going to introduce, if a figure is not, okay, if a figure is not a square, if a figure is not a square, then I'm going to conclude that then it is not a quadrilateral. Okay. All right, so let's go, and I'm going to just say here, we said that this one is false, right? This one is false, and watch what I'm saying here. Converse and inverse statements are equivalent. That means they have the same truth. So if this one is false, what about this one? Is this a true or false statement? And I'll let you answer this one, okay? All right, but let's go and do, I'm gonna introduce another symbol here, okay? This is what it means to, and I'll just add a note. Not is this symbol, the squiggle, just like that, okay? So this is read as not, okay, that squiggle. Not P implies not Q. So if P is not true, if the hypothesis is not true, then the conclusion is not true. It's not true either, okay? So this is how you apply the inverse to a conditional statement. All right. So let's go on to the next part. The next part, and I'm going to show you all of it, okay? So on this one, we have what we call the contrapositive. This is the contrapositive, okay? And the contrapositive and the conditional statement, meaning this statement here, okay? Or in general, any conditional statement, the contrapositive of the conditional statement that you have, the statement, okay, conditional statement and contrapositive are, I'm going to again give you that word, they are equivalent, okay? That means they have the same truth value. So they are equivalent, and you can see that, but that's what I just wrote here, equivalent, okay? Now, what you do here is, so on this one, you apply, I'm going to apply the converse, okay, converse and inverse at the same time. So what that means is I'm going to switch the conditional statement and I'm going to negate it. Okay, so watch how this is done. Okay, so here I'm going to switch. Okay, so this will be Q and this will be P. And I'm going to negate Q and P. Don't forget, Q is the conclusion, P is the hypothesis, okay? So taking this one here, this one says if a figure is a square, then it is a quadrilateral. I'm going to switch this too. So then I'm going to say if a figure, okay, so if a figure, and I'm going to negate it. If a figure is what? How do I negate? Not. If a figure is not, okay, a quadrilateral, then it is not, okay, then it is not a square. So I just negated the conclusion and the hypothesis. So I just switch them and negate them. Okay, so then this one, well, using symbols, you would say not Q implies, that's what the arrow means, don't forget that, implies not P. Okay, So as you practice this, just practice it on the assignment and see if it begins to make sense, okay? And I know this is going to be challenging for some of you, or maybe all of you, and it's okay if it's challenging. Don't forget, you don't know this, so it is expected that you're going to run into some problems here. But I'm always available. You just need to send me a message or an email, and I will get back to you. Okay, I'll talk to you soon. Bye-bye.